All right, guys, on to section 4, number 9. Here we go. On this problem, it's just asking you to convert equations. So a lot of the same words that I use in a lot of my other videos here. Words like each or per means like a rate, an initial value, that's a constant. But there's some other things you want to be aware of, and that's the type of linear equations they like to give you. So some types that you will tend to see, one, which is pretty common, is a quantity equation. And again, that's usually just x plus y equals c. And what I tend to call a cost equation, which has the ax plus by equals c. Now, this doesn't bring up the third type because it doesn't show up in this problem. But the third type's a relationship equation, when they tell you like there's twice as much of one thing as another, or 5 more of one thing than another, something like that. But in number 9, you're going to see those two equations show up. And these are, again, those are your 3 types. 2 of those 3 are getting used here. So we've got a worker. They use a forklift to move boxes that weigh either 40 or 65 pounds each. The word each means we have 2 rates. So again, in this case, this cost equation, I call it cost because it usually represents cost, but it's anything that has 2 rates in it. In this case, it's going to represent our weights. So number 9, these are our weights that we have. So here they say we have those 2 weights. So I know when I'm looking at my equations, I know B is already ruled out. And again, a lot of this is kind of matching up equations. So I'm going to kind of look at my answer choice as I go along here, and B is ruled out because I know it has to have this form to it because of those 2 rates. So those are gone. The forklift can carry up to either 45 boxes or a weight of 2,400 pounds. I'm going to come back to those boxes in just a second. But it can carry up to. Now be careful and understand what up to means. Cannot go beyond that. Up to is everything up to that weight, so anything less than or equal to that weight. So as you look at your answer choices, I'm looking at things that say less than or equal to with my weights, and it has to be less than or equal to 2,400. So if you look, C is now ruled out, because if you look at C, it says that it is less than or equal to 45. That's the number of boxes, not the weight. So everything here is associated with weight. Okay, so now I'm really stuck between either A or, in this case, I have D left as well. But notice with D, that second equation, and really for A and D, it has this cost equation with it. You'll see just the x plus y. What does that represent? Well, that takes us back to that 45. It's the number of things, in this case, the number of boxes. So it's the quantity of boxes. So here we're looking at how many boxes I have. Well, D doesn't say how many boxes I have. It doesn't have the 45. So that's ruled out. It uses that 2,400 twice. So A is going to be our proper answer because it has our proper weight equation and it has our proper equation for our quantity, our number of boxes. So number 9 is going to be A. Moving on to number 10. This one is giving us some equations. I kind of went ahead and wrote them down here so we can just kind of look at what I have. They're giving me some scenarios here without actually giving us the function to work with. They're basically giving us some evaluations. They're saying if I plug in 2 into f of x, I'm going to get 3. And if I plug in 3, I'm going to get 5, and so on. So with this, we need to be able to solve this composition of functions. Well, let's take a look at what we're given here. And this is very quick and easy. G of 3 that you have up here is equal to 2. So this is going to equal f of 2. Well, f of 2 we have is equal to 3. So our answer is 3. Again, I'll do that one more time. So this guy right here, G of 3, we know it equals 2. So basically we are finding f of 2, which we know the answer to. So again, I did that twice there just to help you make sure you see that. So notice I did not need this at all, and I didn't need this at all either. So some of the information they gave you was pointless. No pun intended, pointless. But anyway, that's all we had to do on number 10. Just plug in and you're good to go. So number 11, speaking of problems that give you information you don't need. Number 11 is doing that as well. In the end, this question is asking us, they're giving us all this information. At the end of the day, which of the following is closest to the number of days it would take Tony to read this novel? So we're wanting to focus in on how many days it would take him to read it. So some of the things you have to kind of look at this data and figure out what's important, what do I need to help me figure out how many days it'll take to read the novel, and what we don't need. Well, here's what we need. For one, I know the number of words in the novel. That's kind of important because they don't say, anything else about the entire novel. Well, I have to read the entire novel, so I need to have something that tells me that I've finished. This will tell me that I've finished because I've read all those words. So anything associated with words, I need. Pages would be great, but again, if I look at the words, I see words here, so I'm probably going to need this information as well. Again, pages and words, there's not like words per page, so that's not going to help me. On the number of chapters, kind of goes with the pages. I don't need that. Again, I'm focusing on these words because that's how many the entire novel is. So this is the only way I know if I finish the novel is how many words I've read, not how many pages I've read or chapters or whatnot. So again, I don't need this. I don't need this. Number of parts, I'm not even sure what that would technically represent. It's very vague. And then again, I want to know how many days it's going to take. So this is telling me how often I read in a day. So this is going to be useful information. So it's all about pulling the information that we need to answer this question. So now that we know, again, how many words there are, number of words per minute, hours per day, now I can go ahead and start solving this. So let me start. I'm going to call this number 1, so you know where I'm pulling this from, just in case. I may not need to number these, but I'm doing it just in case here. So if I take the information from number 1, it says number of hours in a day, but notice all this is represented in minutes. So I'm going to go ahead and change that to minutes. So again, 3 hours, I know that that's going to be 180 minutes. Let me get that. There we go. Not really. That's still terrible. Okay. So now that I know this is how much I read in a day, I want to see, how long will it take me to read this, how many days. Well, again, this represents, I'll say 1 day. Just remember that. Now there are a number of words in a minute, so this will tell me I have 180 minutes in 1 day. So now that I know that I can read 250 words per minute, and that's why I say the 1 might not help here, I'm just going to take this information and I'm going to use it. There are 250 words I read every single minute. I read 180 minutes in a day. So I'm going to go 180 times 250, and this will tell me how many words I read per day. So I'm going to go 180 times 250, and I get 45,000 words per day. Again, this is going to be very useful as I'm trying to get this in terms of words. So I now know that I read 45,000 words per day. Well, this is how many words there are in the entire novel. This is how many words I read in a day. I'm going to divide these two numbers, so 349, 168, divided by 45,000. I plug those numbers in, and I'm going to get 7.759 days. That's how long it's going to take me to read this. Now they say, what is the closest to the number of days it would take? Well, in this case, that would equal 8 in this scenario, which is B. So again, number 11 is approximately 8 days. I mean, you've read 7 days and you're into your 8th, so it is 8 days. So that's going to be B for number 11. All right, next up, number 12. This one is having us just write out another inequality. So just like I always do, initial values are your y-intercepts, things like that. Each or per represents slope or rates. So anyway, in this case, on January 1st, 2000, there were 175,000 tons of trash in a landfill that had a capacity of 325,000 tons. So it seems like at first, as I'm looking at my answer choices here, and I feel like, that 175,000, that's what we started with. So we're looking at that as our initial value. So And again, you can always change that if something isn't working, but it looks like we initially in the year 2000, we had 175,000 tons. You know, they're telling us a capacity, but this is an initial value. So right now, I don't know what the heck to do with that 325,000, but I do know that's what I started with. So I'm going to go with that and roll with it. Each year, so that word each is going to be important. Each year since then, the amount of trash in landfill has increased by 7,500 tons. So my rate, the number I'm going to multiply here, it's increased by 7,500. So 7,500 is my rate. So it's a positive. So I have a rate and an initial value. So in this case, if Y represents the time and years after January 1st, 2000, which of the following inequalities describes the set of years where the landfill is at or above? So I know at or above, I'm going to have that greater than or equal to, and I guess it depends on the order you're doing it, but it's at or above capacity. Now remember that 325,000 at or above, I mean I'm going to have greater than or equal to 325,000. So I kind of can put all this together. You can probably see the equation we're going to get. It looks like we're going to have answer choice D, which basically says this: initial value plus my rate is greater than or equal to 325,000. So that, again, is answer choice D. It matches it. This is a pretty straightforward slope-intercept form, in this case, inequality. So that's going to be number 12. Okay, so keep it going here. That's number 12. Moving on to number 13. This one is just a good old process elimination question. It's asking you about a survey that was done, and all you really need to do is just kind of go through each answer choice and see which one would most affect your data or make it, you know, really inconclusive or not getting a reliable solution here, conclusion. So here the things to focus on is that you want to see and determine whether people in a certain large town prefer watching sports on TV or attending the event. So what you want to try to avoid is a scenario like where you go to an event and ask them, do you prefer watching that event at home or at the stadium? Because obviously you're going to get people that tell you, well, I prefer to watch at the stadium because you're at the stadium. Well, here they do this by going to a local restaurant on a weekend. So if you think about it, if you're at a restaurant on the weekend, maybe you're watching sports there, but you're not at a stadium. What you want to do is you want to get a large sample, because it's a large city. You want to get samples from people from all different areas. Maybe even not during sporting hours when sports are usually being played. So if you go there, they do tell you 7 people refuse to respond. That's not a big deal, depending on how many people you ask, because there's 117. So 7's not going to affect it that much. So again, as you go through your answers, which choice would make it least likely a reliable conclusion can be drawn? You know, the sample size. You know, that sample size could be good as long as you were varying. You had a random sampling. This isn't really random. You went to one specific location. So A is not going to be necessarily our answer because, again, you can use the 117 it would be okay if you use it in a productive and random way. So anyway, like I say, the same thing with the population size. Again, it's all about, again, who you're picking. So what if it's a big town or a small town? As long as you have a random sample. And 117 people is good enough to get an idea. Next up, the number of people who refuse to respond is really negligible, so it's not a big deal. But again, where the survey was given, that does matter. Again, we want to make sure we are picking either multiple locations or maybe not a location where people are watching a game on TV. So 13 is just going to be D. All you got to do is just use process elimination, look at each scenario as it comes. All right, and lastly, we have number 14. This one's pretty quick. We just have this chart here that is the miles traveled based off of years for air passengers in a country. But really, just look at the question. I mean, if they give you a paragraph, usually that paragraph is just describing the picture anyway. Jump down to that final sentence, and you'll notice they're just asking, Which of the following best approximates the year in which the number of miles traveled by air passengers in country X was estimated to be 550 billion? Now, in this case, you can't see it, on my screen here, but you're just going to go here to 550 billion. So that's 550, and you'll see on your graph, you'll look somewhere between 500 and 600. And you want to match it up with that line of best fit right in here. Now, in the graph that you're going to see, it's going to be between 2000 and 2010. So when you look at this, you say, well, I need an answer that's somewhere between that. And it's actually a little bit like closer to 2000 if you look at it. So you just find the answer that would match that. 2003 matches that. It looks like it's approximately 2003. Which is answer choice C. You're just, again, matching literally that vertical line with that horizontal line at 550. So you do that and you get your answer, and that's number 14 from test number 2, section 4.